You can't see it. Matthew, please.
Guys, the thing is that okay, please go over sit there. And the next time always look at arrangement. And next time, guys, please everyone sit in this arrangement. Do not sit on your pre-assigned desk. Please always sit like that.
Like next to my bar in front of them.
Yeah, just you can sit there.
Okay.
Thank you.
Bye.
Okay, now, guys, the thing that, guys, please for the next session that we need, you sit exactly in this arrangement until further changes. Now, about the tests, today we had a meeting, I should say, with other teachers. Now we decided how to just convert the marks that you got already into the IB format. Then the next session that I'm just going to meet you, you can just have your papers with the mark, convert it back into the IB spectrum, have it. Yes, Matthew?
So, like, for example, it's a 49, right?
That, no, just it changes now to the IB spectrum.
It's all 49 marks, right?
That's right. That's
How
right.
how many marks you have to get out of 7?
Honestly, I do not know that. The conversion to like that.
I think like minimum like 25.
Okay, now guys, now the thing is that today we are going to talk about some new stuff. Also, it's a continuation of all the things that we have talked about the rational expression. However, what we are going to do today is going to be so amazing. And you can't believe it. Give me a second. Now, look at this. For example, we talked about the rational expressions a couple of sessions ago. We talked about the rational expression a couple of sessions ago, and now what we plan to do, you learned that, for example, if we have two rational expressions, how to multiply them together, and how to divide them together. And also I have given you a very short homework that we are just going to work it. Now, Wednesday? Yes. Now we are just coming to something a little bit different, and that different thing is this. Imagine that I have two rational expressions. One of these, let's say, 3x squared over 8 plus 4, let's say 1x over 4 minus 5 minus x cubed over 6. Oh, now, this, I'm just going to start today a little bit, I should say, it's a very easy task, and that task that you are going to do is this. I say that, okay, I have three expressions. I want to add and subtract them. So far, the things that we have learned, Kate, is this. When we have something very easy, we say, okay, in order to add them together, the thing that always we think is that we look at the basement bottom in any rational expressions. The first of all, what do we do with the basement is that we make sure that the basement is not going to go on fire, and the thing is essentially is that the basement should not become 0. That's the first thing that we always take care of. Now, I look at this, and I say, oh my God, look at this. All the denominators that I have, there is no risk of becoming 0, because all of them are just numbers. Yes, so? And now, then the first task is done. The second task starts from there. The second task starts from there that I have to take a look at the denominators. And look at that. When I learned the math, or I learned like that. I said that if I have A over B plus C over D, I said that when I look into into this and I say I have two denominators, look at this. This is, imagine this is a hand, and also this is a hand. They are just going to shake hands. They are just going to be friends. But how? What do I mean by this? I need, that's right. I need that. I have to look into this, and I make sure that if 8 is going to shake hands with 4, they have to be equal. Because you cannot shake hands when someone is much taller, someone is, for example, shorter. Then that's what the thing. 2 hands, they have to shake hands. Now, as a result, when I look at these, look at, for example, the first 3 expressions. We see that we have 8 cannot shake hands with 4, and 4 cannot shake hands with 6. Now, what do I have to do? I have to come and say, okay, I have to make them to be equal at the same height. Then when they meet, they just extend their hands and shake hands. That's going to be my plan. But how to do this? This one is going to be a little bit, I should say, more fun. Because it requires a little bit of practice. Especially with the homeworks that you are going to have. Now, in order to look at these denominators, 8, 4, and 6. First of all, what is going to be the strategy? I'm going to write the strategy.
Find the LCM.
Huh?
Find the lowest common multiple.
That's right. Step number 1, I'm going to skip this one. But these guys, make easy steps, because when you do your homework, it's going to help a lot. The first step is going to be just, it's going to be find the restrictions. We do not have that step here because at the denominator, we do not have any x to find yet. For example, there is going to be restriction x should not equal to 0. This step, step number 1, and this problem is overlooked. Now, what is going to be the step number 2? Is that thing that I'm just going to say. We say that factorize. The denominators. And sometimes we also factorize the numerators because it's going to make life much easier. But our focus now here is that the second step of this algorithm, Daya, is to factorize just the denominators. Now that's what I'm going to do. I look at this one first. I know that I can. How can I factorize 8?
Or 2 to you can multiply everything you can divide by 2, you can multiply everything to more.
That's right. Or simply, I cannot think. I said 2 times 4, for example. I have many other choices, but let's stick to that.
2 times 2 times 2.
That's right. It is also possible. Now, also, I factorize another term, which is 4.
Can you just put everything to 24? That's quick math.
And now, also, I factorize the other one, 6, which is 2 times 3. I can write this one, 2 times 2. You say, wait a minute, 2 times 2. I remember from the things which I learned in the past that 2 times 2, the base is repeated 2 times, and it reminds me of exponent law. And you say, okay, let's write this 2 to the power 2. Now, guys, the fun part is going to start right now. Please, everyone, look at this part which I'm going to do, Simone. Lisa, Simone, and Daphne. Look at this part which I'm going to do right now because this one is very important. This is the most important minute of the whole session today. The most important 1 minute of the whole 1 hour today. Now, the second step, it told me to factorize all the denominators, Matthew, and that's what I did. Step number 3 is this. I'm just going to teach you step number 3 as what I learned it myself. Now, the plan is that step number 3, let me write this here, then you are going to understand what I mean later. Step number 3, point least common Guys, please listen. Rob, Bird, and Lucas. Look at this one. Lucas, look here. Now I'm just going to find the least common denominators. Look at this. How to find this? How did I learn? Imagine that this is the house. There is a door, and that's the window. And for example, this is me standing on the roof. Now, in order to find the common denominators, what do? I say, okay, I have to decide. I'm inviting 8, 4, and 6, which is all my denominators for a dinner inside the house. Now, what happens? I say, okay, because I do not have enough space, look at this one. You are going to use this analogy for the most complicated parts that you have denominators, very crazy expressions. I say that in my house, I do not have enough space. Then I'm inviting each factorized denominator inside. When 8 is going to come inside, I take a representative. And I say, okay, 8 has 2 and 4. And look at this one. 4 also comes inside and 6 comes inside. What do? From each number, I choose a representative. I say I do not have enough space. Then 8, only one part of it comes inside. I look at this one, I see 2, 4, and I have also 2, and I have also 2 between these terms. Then I say, I do not have enough space to take 2 3 times here. Then I pick up one of them, but I pick up the stronger. Which one is the stronger? Is the one which comes with the power 2. Then, what is going to be invited inside my house for the dinner is one representative of all these 3 guests which has the highest power. Then it says that, okay, 2 to the power 2 is going to be invited. Then let's look at this one. Then 2 from 8 and 2 to the power 2 and 2 also here. You see these terms? Only one of them got invited in. The one with the highest power. Then I say, okay, I'm done. One of these people are inside. Now, who is going to be the next guest? I see, look at this one. From 8, I have 4. I multiply to the 4. From 4, nothing is left. It's already invited. And from 6, I have 3, which is left. Everyone is invited, but the repeated terms, they are invited once. If I invite, for example, Daphne, Sino, and Diana to my house, and all of them are invited, but if they have repeated terms, one of them is coming inside. Now, 2 is invited with the highest power. 4 is invited. I have multiplied to 1. It means that 4 altogether is inside. I have 6, which is 1 term is left. And that term is 3. And 4 is already invited. You see, everything is crossed. Every part is crossed. 2 times 4, I have 2. I have 4. To the power 2 is there. 2 is left out because this one is invited. And 3 times 3. How much is this? 24. 2 times 2 times to the power 2 becomes 4. Lucas, 4 times 4. 16 times 3? 48. This is going to be what? The common denominator. Sorry, 4, no.
Why can't I do 24?
This one is also 4. It's essentially, look at this.
Why are we...
Wait. It becomes 2 to the power 3. Because when you factorize it.
Yeah, but isn't that was the biggest one? So when you need to...
Guys, hold on a second.
I think you're
Yeah,
making it.
Guys, hold on a second.
I think on behalf of the class, I think you're making it a bit like.
Wait. Everyone listen. Matthew. Look at this one. When you factorize 8, 2 to the power 3. Lucas, look at it. Then you see 2 to the power 3, 2 to the power 2, and 2. You get the one with the highest term. You pick up this one. And multiply this, And also look at this, between 2 to the power 3, 2 to the power 2, and 2. Which one is the strongest? Hold on a second.
2 to the power 3.
2 to the power 3. You see that? You take this here as a guess which has the highest power. Now, yes, okay, hold on a second. Hold on a second. Okay, just please bring your hand up. And now also, you see that that term is gone. These terms, because you just pick up the stronger one, are gone. The only term which is left is what? 3. Because I factorized 8 in the wrong way, it should have been written 2 to the power 3. Now,
Yeah, but then
hold on a second, guys. No questions yet. Bravo. No questions yet. Please listen. Now you get 2 to the power 3. Okay, please bring your down. 2 to the power 3 becomes 8. 8 times 3 becomes how much?
24.
24. Wow. And that becomes essentially what you have inside. That's 24. Yes, Kate?
Can I just show,
I think
is
what
there
is-
not a much easier way to do this?
No, wait. I know that you have a easier ways, but that, guys, please everyone take a seat. Okay,
Listen,
seat.
man.
Johnny, yes. No. That's what I just wanted to tell you. The reason that I do this, there are many other ways, because as you move on, you need to follow this. You have to factorize, Kate and Johnny. When you factorize, you have to just find the highest power, multiply the terms. The thing that you have from the prior year, this is called the least common multipliers, but now you're looking for the least common denominators. That's a little bit different. Yes?
If you already know the answer, can you do all those steps?
No. There is no need. Then as a result, when it comes to this part, okay, now, when it comes to this part, you see that. Now that what we do, I'm just going to write in this part. You see that, you just write the least common denominators that we got from step number 3, and all the way here, you go to the step number 4 to simplify this. And to simplify this, it's very easy. You remember from the prior years. You look at the least common denominators that we got. You divide this by 8, becomes how much?
3.
3. Then you just want to be fair. You see that if I multiply the denominator to 3 to become 24, then I have to be fair. I also multiply the numerator to 3, which becomes how much?
9 squared.
9x squared.
Why
The
not,
same
wait,
thing.
why not x squared? Because
Well,
we need
three.
to multiply 8 to get 24.
Like this, because you see that, Lisa, you look at the 24, you say that I have 24 as a common least denominator. It is multiplied 3 to 8 to get 24. Then I say also I have to be fair, multiply this one also to 3. Then that's why it becomes 9x squared. You do the same thing to 4. It's multiplied to 6 to become 24. Then again you want to be fair. Then you multiply also the numerator to this. It becomes plus 6x. And the last one is this. You have minus sign here. And you see that, okay, I have minus sign there. I have 24. 24 times 6, 6 times 4 becomes 24. Then you multiply also that one. It becomes minus 20x to the power 3. Then also you can simplify that further. That's essentially what we wanted to show, how to find the least common denominators. You can find any methods that you want. For example, the least common multipliers, but this is going to be the algorithm that we are going to follow for the rest of the session. Factorize the denominators and multiply. Now,
wait, what are the restrictions?
the restriction, you look at the denominator,
Wait, is it just 8, 4, and 6?
that 8, 4, and 6.
Oh, okay.
Now, we come to the other example. Any questions on this? I have everyone now.
We're not done yet. Are we done on that?
Right.
Are we done with that example? No.
You can simplify that better. But now we are done with that example.
On the test, the test, would you multiply everything by 24 to get rid of the?
No, because if you multiply 24, for example, you have A times B, you multiply that by any number, for example, alpha equals alpha B. But you have only these two. You multiply the two.
To get rid of the 24, do we just multiply everything?
No, because there is not any quantity, it's just an expression.
Oh, yeah, okay, that makes sense. That's right.
Yes. I'm going to explain in the next
So
section.
here, if you were to get that as a question, it would be simplify, not find the value of x.
That's right. Just a simplification, not a value. Now,
Just simplify that. Just gotta copy. Do not solve it for x.
okay, now,
I'm telling you, you can't.
Are you using that problem?
yes, it's a new problem.
Why?
We're just simplifying. What?
Simplify
Alright, but
is this.
listen.
So that's the answer.
That's the answer.
Wait, but then we have to.
No,
Yeah,
because
but
you
yeah,
got-
is it 9x squared? Yeah, you do that. That's all. Yeah.
Okay, now,
Bless you.
That's it.
Okay.
Isn't that right, bud?
Who will you dominate? I'll use it. Fucking volleyball. Yeah.
okay,
What?
now guys, our session, Matthew, please take a seat. Now, the main thing that we just want to do today starts from this. I'm just going to put that in red to specify how's the substraction. Now, I hope from this part you learn how to find the least common denominators, which had it also before. Now, you are just going to get more involved with the rational expressions and using these 4 categories to find the solution for this. I'm just going to solve it with you. We just do step by step. Then the next one you're going to do it yourself. Okay, the first is to get that. No, we do not find the x. We only simplify it. Because look at this. We say that we find the x when we have an equation. This is just an expression. Now, look at this. Now, I'm just going to do step by step. Step number 1. I'm just going to find the restrictions first. And how do I find it? I just simply take a look at this expression. And I say, oh, I have 2 rational expressions. One here, one there. And for both of them, I see that I have a denominator. From the first one, in order to find the restrictions, that's going to be my first step. I take whatever is inside the new denominator, I take it equal to 0. Then as a result, what do I get at the end is this x squared is equal to plus 1. Then how much is going to be the x?
Why don't we do this for the other function?
Because it was just one singular number, not an expression.
There is no restrictions. Thanks, Lisa. Now, then how much is this?
It's gonna be 1.
Only 1 or
Square root of 1, but what is square root of 1?
1? Is this correct, or do you think that it needs some modification?
I say correct.
Well, it is correct. X squared is equal to 1. How much is the x?
It's 10.
The square root of 1.
And how much is square root of 1? 1. Who says that the answer is correct? Raise your hand.
I'm so confused.
If you think that that's correct, raise your hand.
It says wrong now.
Raise
I
higher.
will
Raise
lower
your
my
hand
hand
higher.
because I have a right
I
answer.
feel like this is a.
You say that's right, Ella, and
Why is it
everyone
wrong?
thinks that's right. Keep your hands up.
Why
Oh,
is
you
it
say that
wrong?
twice.
I know.
Is this a trick question?
No,
I
that's the
know.
question.
I
Who says
know.
this is correct?
I know.
Robert, how about you?
What are the answers? I don't think it's right.
You think it's right. You think what you think.
I don't think it's right.
Why is that right, bud?
I know the
Who
answer. I
says
think it's right.
who says it's not correct?
Oh.
You said it's not correct?
It's not correct at all.
It's not plus minus thing. Yeah, I can do that.
That's right. There we go. Don't be, you didn't raise your hand. Raise your hand next to Lucas. Lucas.
What do you mean plus or minus?
Guys. Lucas, please.
Yeah. Why
Grab
would
a-
it plus or minus? Because
Guys, look at
minus 1 times minus 1 equals 1.
remember that we talked about it. We said that if we have x squared is a number. Yes, ma'am.
So like the square root expression always goes to the plus or minus.
That's right. If the exponent is even number, it always goes with the plus and minus. For example, x squared is equal to a. Then we say that x is plus and minus the square root of a. Then as a result, I have 2 plus and minus 1.
Why did it?
My friend of that.
Now, look at the other one. I have this one. I have also the second restriction comes. I have x squared plus 3x minus 4, which is the thing at the base. Rodgo, please you go to sit there. And please keep that one also from the next session. Thank you. Yes, no, Rodgo, the other one. And now, look at this one. That's the second denominator. And also, you please take a seat. Yes, you take your seat. Go all the way to sit at the back. It's a good change.
Hi, Chloe.
Hi.
Lucas. And also next time, Lucas, you don't want to sit there. Next session. There? Yes. And you get your It's gonna be, Lucas, next time I bring the chair like that, you sit there. Not now, not now. Okay, look at this. Now, for the second denominator, that the and that's yes.
We have to do method.
That's 4. The easier one. That's right. For this one, I say 5 goes to 0. And establish that one of the methods is that I use the methods of the determinants, or I can say how can I factorize it? I say I can find 2 numbers, x, here, 2 numbers, that their summation becomes 3, and their multiplications becomes 4, minus 4.
Negative 4 and plus 1. No, opposite. That's what
How about, you said negative 4 and plus 1? If I add them together, I get minus 3.
you add 4, negative 1, 1 and plus
How about this? If I add them,
so
it's
true.
Yeah.
That's so true. Then it becomes plus 4, and also x minus 1 equals to 0. Now, from this, I notice that very easily I can find the restrictions. One of them, x is equal to b plus 1. The other one is going to be x equal to minus 4. Now,
Is it the opposite?
that's it, because everything goes to 0, this one goes to 0, this one goes to 0,
Yeah.
then individually you have each term.
Why is it not both?
Which is S plus 4.
And I told you.
Okay, yeah. Matthew, what are you doing? Yes.
Is it possible that like this week or tomorrow that you can post your good sheet for the next time? Can you start revising?
Yes, absolutely.
Wait, why is it?
November the 2nd, but it comes.
We also have the mock exam and the
Did I give you rocket science?
That's how you gave us a practice exam, remember?
What?
Yes,
Wait,
I
wait,
get
it's
it.
a practice
Yeah, remember?
Yes.
You gave us a
Oh, you did previous test.
No.
You want to-
Yes, of course, of course. But a little bit closer towards the exam. Chloe,
Can you post the vacancies?
next time I'm gonna see the outside then.
Can you please listen like this?
Thank you. No. Just, here with me. Now, at this stage, what we're going to do, Roswell, we find the restrictions. And also, Simon, next time if I do not see you fine, I ask you to just separate your chair coming here. But now it's okay, I can see you fine. Now, next on, the next step is that to factorize the denominator. In order to factorize the denominator, it's become a very easy step because so far I factorized most of it through the step number 1, which I needed to find the restrictions. Now, in order to factorize it, I'm just going to take it here and write it from here. For the first fraction expression, I can write the numerator as 2 over x. However, for the denominator, I can write what? X squared minus 1.
Yeah, x minus 1 and then x plus 1.
That's right, it's the conjugate identity that we learned. I subtracted minus what? X plus 2 over, for the same I should say, quadratic expression that we saw. I know it's going to be very easy because I factorized these terms when I just found its root, which means that it becomes x plus 4 times x minus 1. Now, I factorized everything. And I cannot factorize it further because each individual item, they are just factorizing to a level that none of these items can factorize further. And we just stop there.
Is that the end answer?
No. When we are at step number 2, we notice that there is not any more possibility to factorize any other terms. Now, the next step is that to find the least common denominator. How to find this?
Wait,
Yes.
don't the x minus 1 and the x minus 1 cancel?
Which one?
If it was on flop, then it would be.
Oh.
No, this one. It means that the thing that you said, Chloe, is like this. It belongs, for example, to the house over there, and this one belongs here. They are in a 2 different worlds. But if x minus 1 was on this top, you could just remove one from the other. But not here. Imagine you are at the TFS. There is another Chloe at the other street on the other house. There are 2 in 2 separate worlds.
I'm going.
Now, step number 3. Step number 3. For step number 3, what do we do is that to find Simone, please bring your chair here. I cannot see you fine. Separate your chair like the other. All the way here. I cannot see you fine. Something is wrong with my eyes. Separate it here. Now, for the least common denominators now, what is going to be done? We have 2 terms. Simone, completely. Awesome. Thank you. Now, for the least common denominators, look at this. I'm going to write this one. Least common denominators. Okay, from here. For the least common denominators, it's going to be an easy step. If we have factorized the denominators, the previous step, fully. By fully, what do I mean is that when you look back at this, any individual factor format, it cannot be factored further. If you are there, this step is easy. What do you say? You say that, okay, from the term which I highlighted that in red, you see there are 2 expressions, x minus 1 times x plus 1. Now, and also, in the other term, which I highlighted in the green, I have x plus 4 times x minus 1. You see that there are two terms similar, then you only pick one because you cannot invert both of them at the same time. Then you have only x minus 1.
Why did you choose that one?
Look at that.
It is involved in
Let me write this. Let me write this. Guys, I just write this to Elisa. And then look at this. I express this one. I'm going to explain what happened. I call the first term, I call x minus 1 times x plus 1. And the green one, let me write color code them. I call this A. I call this B. Then for the B, what I have is x plus 4 times x minus 1. Now, what do I plan to do is this, to find the least common denominator out of these two terms. What do I do, Elisa? I take all the terms from the A part, from the expression 1, which it becomes x minus 1 times x plus 1. Imagine you have invited A, you take everything inside the house. Now, you have to multiply that to the B term, expression B. For the expression B, look at this. You see that x minus 1 is exactly like the one which you had above. Then you say, oh, I do not have enough chair at my dining table, then 1 was enough which I invited it. Then you just only do not write x minus 1 because once you took this in. Now, what is left? If x plus 4, then that's why you come to write also x plus 4. And that's what is the least common denominator. And always remember, you take, everyone is welcome from those factorized formula, but if the terms are similar in expressions, you only bring them once. The one with the highest power. Always imagine that example that you are coming inside for the dinner, you do not have enough space, then from the common terms you take only one of them. Now, then you see that the least common denominator is this. Now, I look at this one, still I know that this is minus. For step number 4, I'm going to simplify it. How? Like the one example which I had with the numerical values, I take the least common denominators as my denominator. The name also itself is very expressive. We call that common denominators. Then you take this one as a common denominator. It becomes x minus 1 times x plus 1 times x plus 4. The same thing, common denominator, x minus 1, x plus 1, x plus 4. Now at this stage, we come here, we compare these two things. Brother, are you fine?
Yeah, I just can't see.
Oh, okay. Sorry that because I couldn't see you there, that's why. Awesome, thanks. Now guys, now that's the time for the social justice. What do I mean? Social justice. You look at this term, Lucas, we say that this one, in order to get from here to this, if you compare this one, you see that x plus 4 is multiplied to this, to get from there to here. Then the one which is at the numerator is yelling at you that it says that I just want social justice. That's why you also multiply that term to the numerator. Now, the second part. You look at this one, the second rational expression, and compare this with the one with the common denominator.
You would like x plus 1?
That's right, you see that. The only term which you can see here, but this is not there in the x plus 1.
Simplify, right?
That's right.
Why did we put the x plus 4 up?
I'm lost.
Why is the x plus 4 on the numerator?
No, I'm just going to explain that once more. Look at this. You look at this term, Kate and Lisa. You look at the term, the common denominator that you have. You compare this with the one that you had before. Which term from here is missing there? X plus 4 is here. That's right, Elisa. But x plus 4 is not there. Then that's the reason we call that's the social justice. We also multiply x plus 4 to the numerator. You say, okay, no worries. If I multiply x plus 4 rather to the denominator, Sabrina, I also multiply that to the numerator to make a justice for both of them. To be fair. Yes, Chloe?
Yeah.
That's right? Nice. Now, and Kate, look at this. Also look at this one, the second term.
Yeah.
Yes.
You go to Washington.
Yes, please.
There you go.
You look at this one, compare it to the one before the common denominator.
X plus 1.
You see, that's right. X plus 1 is here. X plus 1 is not missing there. Then you say, no worries. That's the time for the social justice. I multiply x plus 1 also to the numerator. What I'm doing. Then becomes x plus 2 times x plus 1. Now, so far so good, everyone?
Yeah.
Everyone's feeling happy, happy, happy?
Very good.
Nice. Now that we have done the social justice to the numerators x, it's the time that these two ones at the denominator, look at this, they are common. Now they can shake hands. What do I mean? It becomes, I take only the common denominators are the same. Now I write only one of them, which is x minus 1 times x plus 1 times x plus 4. That's the common denominator, yes? Now, look at this. This one comes by itself. It becomes everything easy. 2x, x plus 4. And I look at this x. This one is a trap. The minus sign there. I put the minus there, and I have x plus 2 times x plus 1. Yes, Dave?
Are we not entering like 2x into the x plus 4? Like, are we not transforming into like 2x squared and plus 8x or something?
Either you can do it there, or you can do it right here.
Okay.
I still keep my denominator as the way they are. And I write x minus 1 times x plus 1 times x plus 4. And as what Kate said, is that I'm saying, okay, Matthew, let's take 2x, let's take it inside. I'm going to multiply this to this, and multiply this to this. Then it becomes 2x to the power 2 plus 8x. Look, yes.
Can we just get rid of the x plus 4? Because there's an x plus 4 in the denominator. Can we just cross those out?
You mean this one?
That one and the one that multiplies the 2x.
Then can you cross out
You
x
just
plus
got rid of
1 and
it.
x plus
You mean
1?
this one?
Yeah.
No. If you do that, then you go back to the same thing before taking the common denominators. Imagine if you take this one, x plus 4, the whole expression, this one is going to be divided by this, minus this divided by this. You take this one, cancel them out, you go back again to this, then it's not going to be a good idea. Yes, please. Now, I have minus here. Now I'm going to also do this one. I take this one in
No,
this.
you can cancel out x plus 1, x plus 1. You can cancel out x plus 1, x plus 1.
No.
You mean this one?
You said we're not
No.
allowed to do that.
But I understand that x plus 4. Like,
But we use the same logic to the x plus 1.
That's right. As I said to Lucas, if you cancel these two together, you again go back to the same thing. You just have to forward the step. You cannot cancel. Look at this, guys. If there are terms. For example, look at this. AB over B. Yes, Kate?
Oh, do we have to distribute the minus?
That's what. That's right. And before, just look at this one. People are asking me if we can cancel these terms. Look at the AB over B. You can cancel and write A. But A plus B over B, you have to just divide it from both. You write A divided by B, once it works on this, once it works on this, plus B over B, which is A over B plus 1. And that's the reason Elisa and Lucas, we can always,
So you can do with multiplication and not
Yes.
addition or
not addition. We cannot see this.
And then they multiply to actual scale.
They said,
Never mind.
no, say that, say that.
And then they multiply to actual scale.
You mean this one? Yeah, they're more.
Then can you simplify it?
And that's because of the reason which I said. I'm just going to do this one. If you take them inside, you can see that I keep minus there. And this one becomes x squared plus 3x plus 2. Everybody's okay so far?
Yeah.
Now, you have minus sign there. I'm going to write the common denominator as the way which it is, x plus 4. And you know that from many years ago, that when you have a minus sign there, it's going to be distributed in sign, which means that you can write 2x squared plus 8x. You have minus x squared,
Minus 3x.
that's right, minus 3x.
Minus 2.
That's fantastic. And now, we are 3 seconds before finishing it.
1, 2, 3.
The common denominator, I write the way it is. Now, 2x squared minus x squared becomes how much?
X squared.
Fantastic.
Wait, what?
2x squared minus x squared.
Oh, okay.
8x minus 2x. That's right.
Do we solve the bottom?
No, keep it the way it is. Do not expand the bottom. Don't fall into that. Keep it the way it is, the bottom, the denominator. And also, guys, look at this. I have only minus 2 left. And when you get there, do not expand the denominator. Keep the way which it is. And keep also the numerator like that. And by doing this, it means that we started, oh my God, that looks so fancy. We started from here all the way down. And look at this. I followed this one step by step. First, I found the restrictions. Second, I factorized the denominator. Third, I found the lowest common denominators, the example that you divide these two terms. You do not divide them twice. You find this one. Then you come here to do the social justice. You say that, what is this divided by? Look at this, you compare these ones with that and multiply the numerator by the same factor. That's what they call the social justice. And at the end, there is some minor simplification, which I said that step number 4. You multiply this to this, and that's summation. Yes, next.
So what do we use the restrictions for in this case? Like for solving these?
You never use them actually.
They are actually
No,
I
actually,
don't know why we do.
use it for the denominators.
you look at this one. You find your restrictions, Lex and Lisa. Look at this one. You have restrictions plus and minus 1 and 4. And which you see the restrictions here. What does it tell you? Guys, everyone listen. If you wonder,
It tells you you're right.
no, it tells you, what does it tell you? Why did you just find the restrictions and you carry this forward?
We'll use it later.
Find your restrictions is that. That's right. Guys, everyone listen. In the next couple of sessions, we are going to talk about the functions. And all of them, they are the functions. And when you work with the functions, it's always like that. You have to always know what is your restriction. It's like that. For example, it's a rainy day, you have to carry your umbrella. And the restrictions are like the umbrella for you. You have to always take care of them. Especially you see that in the next sessions. No, next 2 weeks when we talk about the functions.
And there's only restricted when there's an X.
That if there is a restriction, if there is an x at the denominator. Now, any questions, guys? No, I give you the 2 minutes break. That's what the audience is doing. No problem. So I started that earlier because the stuff in the middle. Yes.
Again.
Oh no, rather. Okay, now.
Let's see, you got He's not right. Here's either. I'm about you're ready watching. I'm very careful. I'm watching. So good. Okay, how are you watching that? Standing. So bad. No.
Okay, now.
Sorry about that.
Matthew, Lucas, just take your seat. Yes.
Is the homework that you posted on Friday that's due on Wednesday, is it covered the same stuff or is it different?
No, that homework is different.
So
This is a new one. You're getting new one. Yes.
is this from the second part? Is this
2.7. The second part of it. Awesome. Any questions so far, Lisa? Now, guys, okay. Now, yes, guys, you have 2 assignments to hang up in the door for simulation.
Someone's at the door.
Guys, now, we have 2 very short. I assigned 2 very short. Each one takes maybe 2 minutes to find, I should say, the solutions. Now, when you are done, I give you the homework, which requires a little bit more work.
Homework?
Please, for each, follow these steps. 1, 2, 3, and 4. No, for 2 right now. 2 of them, guys. There are 2 ones. One and this.
Oh my. How do you do
Oh my.
I do on Google.
Okay. Okay, for the first one. I'm going to do the first one because this one seems a little bit, I should say, hardy one. Step number 1, what is the restriction?
X minus 3 equals 0.
Then it gives you x equal to?
3.
That's the first restriction. The second restriction is this. 5x minus 1 equals to 0 means that x should not be 1 over 5. The second is the guys. Guys, everyone look at this one. This is a very, very interesting example because when you look at this, step number 1, it's a very, very easy step. Step number 1 says, okay, find the restrictions. You have x at the denominator, you take it to be 0, then step number 1 is always the easiest part to deal with. Now, rather, we go to the step number 2 and say, wait a minute, there's a little problem there. We try to factorize the denominator. You see that the denominator, they are in a format that we cannot factorize them.
Can you do 0.5?
Sorry, what?
Can we just not make, can we not just use the fraction, just make it 0?
Yeah, you can do that. 0.2.
Sorry.
Don't worry. And now take Then you see that step number 2, Chloe, step number 2, you said we cannot factorize it. Then what happens to the least common denominator? You multiply all the denominators together. Yes.
Why can't you just multiply like the top by the opposite? I don't know if that makes any sense.
So
Why
that's
can you
you are in step number 4.
Like, why can't you multiply? I don't know.
Why can't
You
you
are
factor
right. You are right, Kate, but you are one step ahead.
Why can't you factor it?
Why
Look
can't
at
you
this.
do like 3
Why
times
can't you
3 and then 5x minus 1 in the brackets over x minus 3 minus 7 x minus y? Yeah. Why can't you just skip
Why can't I do that?
So,
There is no need to be confused. Look at this.
so why can't you factor it right over that?
Why can't you?
We cannot factorize it because x minus 3, we cannot factor it. Or 5x minus 1, we cannot factor it.
So you're putting
Then
it
that's
all-
why you multiply all the terms together. That becomes the common denominator. Now, you see that? Oh, you look at the first term. You see that the first term is multiplied to 5x minus 1. Then you say, okay, then let's do the social justice and multiply also the numerator to the same thing that it was back multiplied to the denominator, which becomes 3 times 5x minus 1. Now, we see that we have 5x minus 1, but the common denominator is 5x minus 1 times x minus 3, which it means that you multiply this one to x minus 3. And now social justice, we also multiply the numerator to the one which we miss it on there, which is x minus 3. And you can continue. I'm going to write it here. Continue, you write x minus 3, 5x minus 1. The common denominator, you have 15x minus 3. You have minus 7x plus 21. You can simplify that further. Now, you do this yourself. I'm just going to do the attendance. We have 5 minutes left. You do the second one. Yeah, that's done.
What are the denominators? How am I supposed to see that?
This is done. You can say, okay, you can simplify this further. 8x.
This is a Daniel.
Yes.
So what does it mean minus? I don't understand.
Give me 1 second to do the attendance.
I'm really not done the attendance. No, today, because it's minus 7 times minus
Okay.
3.
8 is there. Daniel.
The minus minus is a plus.
Julia. Thank you. Daphne. Thank you. Matthew. Matthew, come back to your seat.
Okay, back to the second fraction.
Jonah.